simply can't keep up with the adoption rate, even with the technology, even driving down the cost per bit, which means that some other solution needs to be found in this problem. And this is why the operators talk to people like us and many of the other people in the room. I've seen some very good presentations in here. They classify things in two different areas, and we do as well. We have these connected applications and we have streaming applications. Connected applications are really driving small little bits of data that are asking for a channel a lot, compacting the signaling side of the network, and streaming applications are the bandwidth challenge. Surprisingly enough, it's the connected applications which are causing the problem for the operators right now. The streaming applications will become a problem, but today it's really more about these connected applications simply trying to acquire channels on the network. It's interesting because in our tests, if we take a phone, an Android phone for example, download the weather app, Facebook, Twitter, set up your account and leave it on your desk and not touch it, just let it do its thing, you'll consume 30 megabytes a month of data just sitting there, not touched. And that's those applications simply checking in the background, creating chatter, asking for signals. We multiply that by the different platforms, the different OSs, connected applications, and the problem loses scale, quite quickly. So we took a look at this and we thought we needed a more holistic approach because you have applications, but you also have behavioral problems. We see this in Japan and Korea a lot. Twitter throws "I'm busy" error, and the response is, I just hit the refresh button harder until I get my data back. In areas where we see high penetration rates in mobile, this is a network meltdown kind of effect. We have lots of people suddenly making a request to a server that's never going to return anything. And geographic congestion is another problem. The networks are simply not designed to scale so that you have gazillions of people in one single co-located area. Try using your mobile phone at CTIA sometime, and it's a very difficult thing, or even Mobile World Congress. We simply can't make that scale work. If you're going to really step back and take a look at this problem, you need to look at it from not only all three of these points of view, but also from the protocol aspects as well. I think this morning we heard some statements about how TCP is a problem in the network. Well, it's a problem even beyond what was discussed. The protocol itself creates signaling events that cause the network to have problems. Right? And so we need to really lift ourselves up and say that this problem needs to be addressed truly at other points in the network. You're not going to be able to police this in. Developers are going to need to scale. You're not going to be able to come up with one new radio technology, 4G, which is wonderful and it's cost per bit and its scale, but there's going to be too many people, just simply too many people in the new generation. Developers are going to develop apps across the environment so that they work in a Wi-Fi environment, a wired environment, a mobile environment, a disconnected environment that scale across these devices. The user's behavior is going to be a problem, so how do we fix it? At 7, what we said is that what you really need to do is think about it in terms of what's causing the problem and how do you grab control of that. And if you could take the content and somehow figure out, is there some element to that content that is repeatable, or some element of that content that is deterministic? And if you can do that without having any knowledge of the application, well, I can take that content and keep it off the network and serve it up for as long as it's fresh. Right? And then if you can manage this in a way where two entities don't actually need to communicate the freshness of it on a regular